Alright, so when we start talking about the physical internet, we're talking about cables. And what we're going to do here is we're going to look at a cable a little more carefully than you may have looked at a cable before, and then we're going to play a fun game, which is called Follow the Cable. So if you can find a cable that helps connect you to an internet, then your internet connection, you can figure out sort of how it works by just sort of trying to follow that wire back towards wherever it happens to go. Okay? So with some help from Greg, the first thing we're going to do is take a close look at this cable. This is pretty common cabling for various types of residential and commercial internet. This is called Cat 5 cable, Category 5 cable. The details of this cable are too boring and long to get into, but this particular cable, as I'll try to show you right here, actually has 8 connections that come out to it. So if you look at this, this has 8 little landing pads for that connection, and the plug here as well has 8 places where those cables come in. There are 4 twisted pairs. Each pair has 2 wires. So inside this cable, as you can see right here, there are 4 cables, sort of internal cables. Each one of those cables is made up of 2 wires. And what's really interesting about this cable to me is that there's been a lot of engineering that's gone into building this cable to try to make sure that it works well. And one thing that happens when you run a bunch of wires close to each other is that they start to cause electromagnetic interference that can actually disturb the signals on the wires next to them. And one of the ways this is mitigated in this particular type of cable is by twirling the cables around each other or winding the cables at different rates. So if you look carefully, it's a little bit tough to see, this green cable is wound quite tightly. So that cable makes a bunch of turns in a small amount of space, whereas this reddish sort of rust-colored cable is wound a lot more loosely, so it's turning a lot slower. And this is intentional. Not only does this winding pattern, is it different between the cables at any particular point on the cable, but it also can change as the cable goes along. So this is all done, this is sort of all highly engineered to try to make sure that I can send as much data down this cable as possible. And there's, one of the ways that we achieve capacity through this cable is just by having a lot of wires inside of it. So there's some sort of physical limit to how much data I can send down a cable that's a function of properties of the wire itself. And if I want to send more data, well, I can pack in 2 wires or 4 wires or 8 wires. Category 5 cable actually doesn't specify how many wires are inside of it. So you can have Category 5 cable that has 20 pairs of cables inside of it, right? But this is a type of cable that's known as twisted pair, because inside the cable itself are a bunch of different cables that are twisted around each other.